Hello, my name is Dylan Radulski, and this is Lab 1 Charge Tapes for Physics 2212 at Georgia Tech. The purpose of this lab was to investigate electrical charge using simple materials that we observed the electrostatic interactions between. We observed the interaction between two pieces of tape to estimate the excess charges on the pieces. We then used the VPython in order to create both a point and line model of the tape interaction to estimate the charges. The main result from the simulation found the charge of the tape to be 1.31 times 10 to the negative 8 coulombs. Some important physical concepts used were the force of gravity near Earth's surface, Coulomb's law, the formula for an electric field, and equilibrium forces. Results from the tape experiment. The tape length was around 0.2 meters, and the mass of that ended up being around 0.0002 kilograms. Since the tape was slightly attracted to the pen that I charged by rubbing it with a cloth, we can determine that the tape is positively charged after it is ripped from the other piece of tape. As for the lab setup, all tape lengths and masses are the same as stated before. Tape B started floating at a distance of around 0.028 meters. This was the setup I used. The system was simply piece of tape B, and the surroundings were tape A and Earth. Here are my calculations. You can see the work above. I found the force of gravity on the tape. Sorry about that. For the calculations, the force of gravity on the tape ended up being 1.96 times 10 to the negative 3 newtons, which was also equal to the electric force on the tape. The excess charge of the tape from the calculations was 7.8 times 10 to the negative 8 coulombs. The number of lost electrons was 4.88 times 10 to the negative 11th, and which left a ratio of 2.14 times 10 to the negative 7 electrons per atom. Here is the point charge simulation. You can see a lot of this work came from Lab 0, which was optional but helped a lot with this assignment. The tape's charge ended up being 1.31 times 10 to the negative 8 coulombs. And for the line charge simulation, it ended up being decently close to the same amount at around 1.962 times 10 to the negative 3. You can see in the code where I inserted the mass of the tape as well as the estimated charge from the previous experiment here. And this function is to calculate the electric field produced by the tape. And down here is to create the lines and arrows that represent the electrons and all the forces. Some sources of error in the experiment were imperfect measuring of the length of tapes, imperfect alignment of tape A underneath tape B, and other sources of electrostatic interference that were unaccounted for. What if and why? What if electrons are negatively charged and protons are positively charged? What if the signs of their charges were reversed, meaning if electrons were positive and protons were negative, what would change about the observations you made with your tapes and other charges? All of our observations would be the same, except that the tapes would now shed protons instead of electrons, but all physical properties would remain the same. As for the why, compare the estimated value of the charge you get when you use your experimental data to produce a point charge model first code to the value you got with the line charge model, the second code. The two computational values for Q, point charge model versus line charge model, will be different. Why are they different? Which value is most likely to be closer to the real value, and why? The point charge model assumes all of the charges of the tape is centered into one point, which simplifies the calculation. The line charge accounts for the line-like geometry of the real piece of tape. The line model would be much more accurate since it accounts for the distribution of charges in the tape.